welcome. Kia ora. This is a very special event today. I've been running Auckland professional group for the past 7 years. This is the first hybrid event I've ever done, so feels special. In the past, we've done live in-person event prior to the lockdown, and during lockdown, we've done some Zoom event. In the past 7 years, the Auckland professional group has ran about over 70 events. With different type of topic, from professional development to IT specific focus event, and for casual Friday catch up, Friday drinks, networking drinks, so on and so forth. So today, like I said, it's very special. We have a live crowd here, and then we also have a bunch of people joining us online, and we might have some people from all over the world today. This event is proudly sponsored by SubQuery. So this is where you are at SubQuery's headquarters in Auckland. And we've got another sponsor, OneBlock, who couldn't be here because they couldn't get their visa to enter New Zealand. They're based in China. So they are the one of the top blockchain education provider in the Asia Pacific region. So they run courses, and most of their courses are free. Even for the ones that are not free, you get your money back when you pass all the exams. So they actually really want you to try hard, study hard, and get through the exam. Who's ever done a OneBlock course before? Okay, I'm the only one. All right, I'm the test kid. That's okay. So really happy to have our two very special guest speaker. And the first guest speaker, James Daly, who's sitting here. James is the business development manager for SubQuery and OnFinality. And I think James previously has an IT background. He used to be a software developer in the past. He joined a few startups, and this is what he do on a daily basis. So his topic today is about Web3, about infrastructure as a service, data as a service for the blockchain community. Let's welcome James.
Thanks, guys. Just want to check everyone on the video call. Can they hear or see my slides?
Yep, looking good.
Perfect. All right. I'm trying out a new clicker. See if it works. Oh, that's so cool. All right. So I've got big shoes to fill with. Gareth's talking after me, so I'll try to make this as good as possible. Hands up, who knows anything about blockchain? Okay, so good. We'll try to cover it all. Essentially, I'm head of business development, thanks to the intro, of SubQuery and OnFinality. We're two New Zealand blockchain companies, kind of the same team, but two different brand names to do two different things. And what I'm going to do today is do a very high-level conversation and talk about blockchain. What it is, what it means, what the difference is. What is Web3? There's this term we use in blockchain, Web3. Why is there so much hype around it? What are some of the technical challenges that face us in the space? What we do here at SubQuery and OnFinality in terms of infrastructure and other tools for this industry, and what's coming over the next few years. So it's going to be a pretty wide variety of conversations. I'll try to take you from knowing nothing about blockchain to knowing a little bit enough to be dangerous. So let's get started. So Web3, what is this random term out there? Web3 is a term coined by a guy called Gavin Wood in 2014. Gavin Wood is a core developer of Ethereum. He kind of co-founded Ethereum almost, which if you know something about blockchain, Gavin Wood's a kind of a big deal. He's a bit of a celebrity. Especially in China, actually. In China, he's an absolute god for some reason. Web3, if you look at history, Web 1 is kind of characterized as static pages on a static website. Those are old Yahoo days where you'd find this cool website, you do a little bit of stuff and you have some fun, and that was it, right? Very old-fashioned. Web 2 is what we use today. It's user-generated content. So Facebook's the world, the social medias, being able to publish stuff, share it around, interoperable sharing on websites around communities. That's what we live in right now, Web 2. Web 3 is this new idea, and it's a little bit vague to describe in one place. And Gavin describes it as, I think I'd say, trustless without trust us with confidence or something like this. This is this random term to describe it. Essentially, it's this kind of world where your experiences and what you create is portable. It's portable in a way that isn't in Web 2. So Web 2, if I upload a photo to Instagram, I can kind of maybe share it from Instagram to Facebook at the same time, but I can't really like take that photo or those likes to a different platform very easily. GDPR's kind of tried to do some stuff around that, but it hasn't really succeeded. If I'm on a video game and I earn a particular ornament for my character, I can't transport that to another video game. I can't buy something here and then take it to this other platform, right? So that's one of the core problems of Web 2 that Web 3 is kind of solving. So it's about the ownership. It's really about ownership of what you do online. The ownership is yours. It's portable. You can take it around. You're not tied into a platform or a product. And also, you don't have to trust the provider of that service. If Facebook goes down tomorrow, you lose everything you've ever done on Facebook. There are internet data storage providers that have gone down with like a month's notice, and people have lost huge swathes of their family albums because they've been stored on these providers. Web 3 is built from the foundations that no one person will own that data, no one person can control that data. If it goes down because of the collective agreement of many parties, not one person. And Web 3 is kind of enabled by a few different innovations out there. Namely, the one is cryptography. Cryptography is, I like to think, if the wheel is the greatest invention of early humankind, cryptography is the greatest invention of our current kind of generation. It's such an amazing thing. Open source code as well, the ability to be able to inspect different ideas in Web 3, have a look at the code, the logic that underpins this application or this service, to inspect how it works, to figure out how it works, to confirm that it works as it should, and to trust that it kind of works. And decentralized applications and services. And this is another word for something that's solved by the blockchain. So decentralization through the blockchain. Blockchain is this massive hypey word. And what is it? It's really just a decentralized storage layer. That's really the basics of blockchain. Decentralized and distributed ledger. But it's a bit more than that. And it's been a bit more than that since 2015 when Ethereum kicked off. It's not just a decentralized storage layer, it's a decentralized computational layer. So think of blockchain like a linked list. It's kind of in the name, a chain of blocks. Every 10 seconds, let's say, a new block is added to that chain. It's like a book of pages. Every 10 seconds, a new page is written to that book. All those pages are immutable, which is a nice way of saying that you can never amend a page, you can never overwrite a page. They're there for history. You can only create a new page which then cancels out the previous page. So if you have this book with magical pages that get written every 10 seconds, let's say, the key part about blockchain, the key magic about blockchain is this book. It's a magical book. Everyone around the world can have a copy of the same book. That same book can operate in every different region in the world. Everyone can have a copy of it, and magically, every 10 seconds, that same page is written to all of those copies of that book, almost simultaneously. So everyone can know what's happened in the last 10 seconds. Everyone can verify what happens in the last 10 seconds. Everyone can confirm what happens in the last 10 seconds. And everyone can trust that. Blockchain does not equal Bitcoin or cryptocurrencies. The association of blockchain and cryptocurrencies is like associating internet with internet banking. Cryptocurrencies and Bitcoin are the most popular implementation of blockchain, but they're not all that it is. And really the big challenge for us in our industry is figuring out use cases for blockchain. We know what this provides, we know what value it provides. It means that we can run these processes in a distributed manner. Kind of only jump back here for a second, actually. One of the big innovations of blockchain about in 2017 with Ethereum was not just storing data, but computational data. So this magical book, yes, it stores what's happened in that book every 10 seconds, but every 10 seconds, you can write a script that will run independently. You can write a script that says, if someone sends money from this account, notify me. And if you save that to the blockchain, then that script will forever run whenever X happens. You can write these scripts in a way, you can codify logic on this blockchain that it can happen independently of yourself. It can happen anywhere in the world. And by writing these scripts, you can do pretty cool stuff. You can write scripts that automatically reward people when bad weather occurs, or scripts that manage the interest rate of a loan, or calculate the interest rate of a loan. So with these scripts and the data storage media, there's many different applications that we're yet to come up with. Things like, obviously at the moment, you're seeing Bitcoin and cryptocurrencies. There's a big industry of DeFi right now, DeFi, decentralized finance, which is codifying the rules around how our financial system operates, which is pretty straightforward. Our financial system is a pretty codified process. Codifying how interest rates are calculated, and then putting in the blockchain. So I can go to the blockchain and I can loan money or lend money or borrow money that's secured against myself, and I can borrow that at a much better rate than I can going to some fat banker down in the physical bank. I can send money around the world in a finite amount of time and cost than I would have to go through the traditional banking system. I can go and create an incredibly complicated financial product based on all the different sale prices of apartments in this 1 square kilometer radius. And I can trade that against all my friends and do derivatives on that trade, on that product, without having to go to a banker at Goldman Sachs paying $1 million to finance it and getting ripped off every step it takes, right? I can decide, as long as I can codify the logic behind a product or behind some process, I can put in the blockchain, and I can do that in a way that's cheaper, trustless, and distributed. So there's many different applications outside of DeFi as well. I want to keep track of every step of this diamond's journey from being mine to going on the ring that I'm giving my girlfriend or my fiance. And I want to confirm that this diamond comes from Namibia and not from somewhere in the Congo. And I can verify every step of the journey because someone has signed that and it's transparent. I want to, yeah, you get things. So we're trying to come up, where we are in the world right now is we're trying to come up with all these different applications. We're trying to put them into practice, and we're trying to integrate them into the real world. So why do we need crypto assets or cryptocurrencies though? Like why are we still doing these random Bitcoin and cryptocurrencies? Well, it really comes down to the way that blockchain runs is that everyone around the world will run this magic book. And this magic book's kind of expensive to run, right? It's like a computer. Yes, Bitcoin is very expensive because it is mining. We'll get to that later. But even so, running this magic book costs money. Now, if we want everyone to randomly run this magic book, and we need a lot of people to run it to be sure that it's decentralized, and that if I go down or if New Zealand gets cut off from the internet, it still operates. We need a lot of people running that, and we can't really rely on goodwill. We need to incentivize people. We need to reward people. So the whole point of crypto assets in every blockchain is literally just to make sure the network still runs by rewarding people with something that has a tangible value. And every crypto asset generally has a fiat value attached to that. So it's an unfortunate situation, but it's what's required to make sure that the network continue to run in a way that if I die tomorrow, the network I create will continue to outlive me for eternity. And really the challenge is how to design an economic model inside of your blockchain that ensures that the price of that crypto asset goes up, and so it stays valuable. So why the hype? At its peak 2 months ago, the blockchain industry was worth a combined about $3 trillion. It's covered here, $3 trillion, and that was just back in November. At the moment, it's kind of come down a bit, which I'm sure you've all heard in the news. And unfortunately, a lot of that stemmed from cryptos, cryptocurrencies, NFTs, speculation, get rich quick, because it's a direct financial model. Because of this inescapable reality that we need a cryptocurrency to secure the network, it means it's an opportunity for people to make a quick buck. And so people on a surface look at blockchain as a place where you can go to the casino, put some money in, and potentially make 100 times return in the space of a few weeks, which you can do, okay? But for us working in this industry, it's an absolute pain in the ass dealing with all this stuff. Like, we don't want to hear about the market going up and down. It's the last thing people in this industry want to hear about. We would, like, if we could, we would banish speculators out of the industry and say, please go away, go trade on stocks or something. But because it's so cheap, it's so accessible, it's so unregulated, you know, you get these YouTubers that hype up some coins and money, it goes up, it invites everyone in. And that's an unfortunate reality of what our world is. But regardless, this blockchain ecosystem, $3 trillion, is the fifth largest country in the world, essentially. It's ahead of India's GDP in terms of the value of cryptocurrencies right now. We don't quite realize that in New Zealand because we have very stable governance, and we know that we can rely on the legal system to, if the banks screw us over, we have consumer protection, we can go to the legal system. We're pretty confident that you can't get screwed over by a financial institution. And a lot of countries around the world, they don't have that same privilege. And so wherever you have slightly unstable government, slightly kind of dictatorship, you know, systems, blockchain is huge. It's massive. Most of our customers here are overseas. Places like Asia, China's a big one, but there's also a lot of people in Europe that are very, I don't know, it's the Europeans that are very like anarchistic in a way sometimes. So yeah, the hype's an unfortunate reality of our industry. That's something that we don't embrace here. So throughout this hype, and if I go back a slide here, you can kind of see, you can't really see, if I just like minimize the people here, you can't really see this, like, so you can kind of see we had this big drop last year, and then it's dropped again. And there was this, back in 2018, we had the biggest crash of all time. This is what we call the crypto winter. This period of almost 2 years was a long winter for our industry, where financial investment was a bit scarce to come by. But regardless, back in 2018, when the market crashed, the number of developers that we have from the industry back in 2018 didn't really change. Us developers kind of stayed here. You know, we let go of all that, you know, market crash and the money going out of the ecosystem and stayed here. And in the past year, the number of developers working in this industry has doubled. And it's a big push and a big bull run this last year. At the moment, it's dropped off, and we might see this flatten again. But still, every time we have a bull run, it means more developers coming into our ecosystem, and those developers stay. Because what we do is new, it's kind of groundbreaking, it's really strange, it requires creative thinking. For me personally, it kind of feels like we're somewhere between like 1998 and 2004. For those that remember the dot-com crash, you know, we all kind of, maybe at the time, rode off this huge bubble that crashed spectacularly, and the NASDAQ lost 75% of its value over 2 years. And we wrote that all off as this internet thing as bonkers, and it's all, you know, it's all smoke and mirrors. But 20 years now, everything's online. You know, that dot-com boom kind of just was a foreshadowing of what is now. So is that something that we'll see with blockchain as well? So next topic, the challenges of Web3, the challenges of blockchain. There are three main challenges that revolve around developing and building stuff in blockchain. The first one is the number of different blockchains. Again, we're all furiously building right now. They're all kind of gone off and built our own like blockchain, right? And Ethereum's the big daddy. We have, I like to call it three generations of blockchains. The first generation is Bitcoin. Bitcoin came out in 2007. The code hasn't really changed since 2007. If you want a proof that there are aliens on Earth or we're in the Matrix, Bitcoin is your proof. There's one guy called Satoshi Nakamoto. He spent 2 years sending emails to people around the world, and he's sitting on a vault of like 50 billion Bitcoin right now on his private keys. We know it's his account because he sent money from it, or her account, or their account. But since then, it hasn't moved. So if we haven't found who that guy is, it's crazy. Because if someone finds them, they made it. Ethereum is generation 2. Ethereum is when we looked at, okay, it's not just a cryptocurrency thing. You can actually run logic on this blockchain, and Ethereum took off from that. And it's still where all the interest is. The retail buyers, the average mum and dad investors of Bitcoin, most people that know a little bit of blockchain are in Ethereum. Ethereum is where the NFTs you buy right now. It's where all the other stuff, where the assets you probably buy and trade are. The problem with Ethereum is it was built in 2015. It hasn't scaled. One of the biggest issues with the first 2 generations of blockchains is it's decentralized. And so that means you kind of have to get everyone to agree to change that code, to change the rules of the game. And getting 51% of a network, and 51% of the network of miners that are making quite a bit of money, have a good financial incentive for things to stay at the status quo, to agree to change something, it's pretty near impossible. So those are the 2 biggest problems with generation 1 and 2 blockchains is change. And so we now have generation 3 blockchains coming through. Polkadot, Solana, Cosmos. This is the number of developers on the y-axis. We work in Polkadot here. Polkadot and many of the others build in governance and change management into the network. And they build in the ability for different networks to do different things. And they also, you might hear all the time, environmental catastrophe. Bitcoin is using the same amount of power as a small nation. Yes, that's true, because Bitcoin and Ethereum is built on something called proof of work. And the idea here is that you've got to reward people for maintaining the network with Bitcoin or Ethereum. The way that you verify that they're maintaining the network in this situation is called proof of work. And you basically reward them based on the computational power they put into the network. And the idea there is the more computational power, the more stable the network, which makes sense. But it means that people will chuck huge supercomputers, mining rigs, to throw as much computational power that's wasted into running these 2 networks at great cost of power. These new networks do something different, which is called proof of stake. And rather than saying the more computational power you put in, the more reward you get, the difference of these new ones is saying the more money that you deposit against your reputation of running the network, the more you earn. So you're encouraging people to basically deposit and saying, I will keep going. I promise you, I'm putting my chips on the table that I'll keep this running. And so as a result, the computational power is just minimal because you don't have that incentive to throw in huge supercomputers. Now, all these networks mean huge diversity in networks. And there was a bit of a fragmentation. There's tens, probably hundreds of different blockchain networks out there. Each operate independently within their own ecosystems. It's a bit of a nightmare, okay? You buy assets here, you can maybe just transfer it here, but you have to go through a centralized exchange. It's a nightmare again. It's 1997, the internet, things are a bit broken, okay? The user experience sucks. So a huge focus on building right now cross-chain messaging protocols, being able to say, I have something here, or I have an NFT here, I'm going to transfer that to a different network. Or bridges. So unfortunately, that's something about our industry. We rushed off to quickly build stuff. We rushed off to build a new world. We all had our own different ideas, and we're still expanding, and maybe one time we'll start coalescing around different things. We'll probably expect that soon. Polkadot, the network that we run in, is a bit of a solution to that. Polkadot is the whole idea about Polkadot, and there's this cool graph here. Polkadot is saying, look, we're always going to have many different blockchain networks, but the kick here is making sure they can all talk to each other, okay? That's number one important. So you can do whatever the hell you want on your own blockchain network, but you have to be able to talk to each other. Imagine Polkadot, where Ethereum is kind of like an apartment building, where you have one big apartment building, and inside your room, you can do whatever you want inside your smart contract. It's quite confined, but you can do some logic there. Polkadot's like a massive subdivision where you can build a huge apartment building like Ethereum, or you can build this zoo, or you can build some weird kind of business office. But the roads and the utilities will link up, and they can all talk to each other. So each different blockchain network of Polkadot operates in its own way, with its own kind of ways that it secures and verifies the network. But it all talks to the core Polkadot, what we call a relay chain, the core Polkadot network. And that allows you to pass messages through, pass actions through. Everyone's speaking the same language, everyone's on the same time frame. It makes it a lot easier to manage this. But what this means though is there's actually quite a lot of different networks. Where there was before in this graph, like 10 different networks, Polkadot is meaning we're going to have hundreds, okay? Which is an opportunity for us here. I'll get to that soon. The second challenge, expensive and non-portable infrastructure. If you want to run a blockchain node, it's cutting edge technology. It's probably in Rust or Solidity. If you want to run a node, you have to be a DevOps person. You got to really know how to run either Docker or have the skills to do some pretty low-level bash scripting to spin it up. Then you got to manage it, and these things break all the time. And they're expensive to run, right? It's an absolute nightmare. We haven't yet figured out a way to effectively run these inside sandbox environments, like on our phone, on a mobile phone, or on a browser window. You can run it locally on your computer, but it's kind of always have to run. It has to have some pretty kind of high-level privileges. It's an ugly kind of bit of code because it's very expensive. It runs quite optimal, but yeah, it's just difficult. So what the solution for this, and what we do at Untitled here, means people don't really want to run their own nodes. We've found that, and people would rather pay someone else to manage a highly performant node and give them access to it. When you write a server, you don't run your own server for your app, you put it to AWS. And what Untitled is kind of like an AWS of blockchain. We run highly performant, highly scalable nodes for all of the different Polkadot networks. And there are now about 35 of these different networks. And every week, we've got 5 backlog this week, actually. Alan's got a couple in the backlog to add on this week. We have a server room around the back of the office there, where we're spinning up our own hardware to run these nodes, because AWS infrastructure doesn't actually, you don't have the ability to select specific combinations of RAM and CPU that you need to run a blockchain network effectively and efficiently. So we run huge volumes of infrastructure for different blockchain networks, and we had our biggest day yesterday. We did 1 billion API requests through our servers in a single day over 35 different networks, which is like 12,000 requests every second. It's ridiculous. Our AWS bill is through the roof. But that's what people do. And yes, there's an argument that this isn't decentralized because you're still kind of relying on one party to kind of give you the data and say this is what you've requested. But it's a heck of a lot convenient than running your own node on your computer. And there's plenty of people out there running blockchain nodes. So Untitled is a massive infrastructure provider for the Polkadot network, and will be for more other networks soon. There's plenty of opportunity, and all of these different players down on this graph down here. So yeah, scalable, reliable, and performant tools. We provide tools at all levels of a developer's journey. So we help developers. One of the biggest challenges as a blockchain developer, you're writing the logic, not just like how the blockchain node runs on a computer, but like how do different blockchain nodes agree that something's happened? So Bitcoin is easy. Bitcoin, the logic's like, we've checked that you have 20 Bitcoins in your account, and we checked that you've signed this transaction with your signature. And if those two are met, then everyone around the world can agree that you sent me $20 or 20 Bitcoin, which is worth a lot more than $20. But testing that out, you can't just deploy it to a staging server. You have to test an entire network. So it's not just deploying one node, it's deploying tens, if not, many multiples of nodes around the world, running those at the same time, starting them up in a way that they kind of connect to each other and they start talking to each other and they run the same blockchain rather than different blockchains. There's a bit of an orchestration aspect to this. That's what we do at Untitled with many of the biggest blockchain development teams out there. And then as they get through and they become to their main network, which is when they kind of go public, they want to invite developers in, building those wallet apps, building all the other apps that they have. And we run that API service I mentioned. We do 1 billion requests in a day. This is old. I'll skip through that. So the third challenge of Web3 in a blockchain, the user experience is crap. It really sucks. And it's the problem of what happens when you get really smart developers going off and just designing by development. It's the most atrociously difficult and complex user experience. It's really advanced. You can do a lot of stuff. It's really cool when you know how to read it and get into it. but it's a nightmare for the average person. And that moat or that gap between the average person and what you need to know to kind of live and do well is constantly kind of expanding as we're building newer and newer stuff and layers upon layers of complexity. We need to focus now on building those applications. So partly due to that developer-driven design and the lack of education, us developers are running off doing this really cool stuff that excite us, but we're not stopping to think about the average person. The real trick or the real key or the real measure of our success will be if I can get my parents to use it. If I can get my parents to actually get access to it. And my parents are absolute Luddites. So the biggest symptom of this is the applications that we've built. These applications are slow, they're difficult to use. Like your experience buying Bitcoin, you might go through an exchange, which will then ask you to set up MetaMask and generate a private key for your wallet with the seed phrase that you store somewhere. You don't realize at the time that if I lose that seed phrase, I lose everything and I can't recover that. Yeah, it's a nightmare. So SubQuery is a tool that we've built here to help solve that. Now, I mentioned at the start, a blockchain is kind of like a linked list. And if you did computer science, you'll know that a linked list is historically inefficient to query. It's the most inefficient way to store data if you want to query that. Because if I want to, that book example, if I want to tell you how many times this character appears in a book, or give me the last 10 times that character appears in that book, you have to go through every page sequentially looking for that character's name, which when you have tens of millions of blocks or hundreds of millions of blocks, it takes hours, if not days. So SubQuery is an indexing solution. And in a traditional software world, you think about it as like an ETL pipeline. It takes data from blockchain, constantly keeps up to date, indexes it. So we have an extraction layer that extracts data from different blockchains, transforms them in a simple mapping function, saves it into a high-performance database. Yes, databases still work really well, and they've had 20 years of innovation. Why wouldn't you use databases? And then give you a query language that you can query that using GraphQL. So that book example is similar to like a wallet. I want to get the last 10 transactions I've ever made. I need to use a tool like SubQuery to get that. So we work with some of the biggest teams in Polkadot, and we provide our services to some of the biggest wallets, like NFT explorers, block explorers, where you can see what's happened on the network. Many different applications use us for different reasons. We don't know, which is a tool that they use. It's open source. You can fork it from GitHub, but we also provide a managed service where we run that indexer for you that constantly indexes data and puts into a format that you can use in your application. Yeah, we have an SDK, we have a hosted service, and we have an Explorer where we have thousands of projects being used. But one of the things that I mentioned here is it's not quite decentralized. So again, it's the same issue here that there's these services that everyone will start using on this decentralized world that are kind of still centralized, right? On finality, it's kind of inescapable. We're running those. A node has to run in one place. And we have economies of scale by running them together and running them in a high performance environment. SubQuery, though, we're running a server. You can run it yourself, but we often run it for our customers because we do a lot of them. We're trying to build a decentralized version of that. So the Web3 dream depends on the further decentralization of our world. And it's a push. And with SubQuery, it's a real push for us right now. We're building a decentralized version. The way you decentralize is you start these atomic processes. So sending money around the world, doing really small things, and then evolving that into full-featured applications like internet banking on blockchain. But the aim of every blockchain company, including SubQuery, is not become a company anymore. It's kind of weird, but the aim of every company in blockchain is eventually to not become a company and become what's called a DAO, a decentralized autonomous organization, where if the government go and say, please shut down, there's nothing they can do because it's running in perpetuity anonymously around the world. And that's what we're trying to do with SubQuery. Now, the way that we do that is you have to run, we have expensive indexes that take data from blockchain and convert it to a format that can be queried. Okay, people have to run that. Now, we have people over here that are building these wallets that want that data. Why don't we build a marketplace here where if you want that data, you can pay in some SubQuery tokens, and the indexer gets rewarded in those SubQuery tokens for providing that service. And people can write these different projects and offer them out there, and you can have all these different payment models for that. And that's what we're trying to do with the SubQuery network, is building a decentralized version that will run in a way. And there's a few other economic tricks we're chucking in there. One of them is you always want to minimize the number of tokens out there that aren't used in a utility or that don't have any utility, like tokens sitting in someone's wallet, ready to be traded, because trading is we want to discourage. So you provide a tool that allows people to deposit tokens in kind of interest-bearing ways. And you can maybe get a cut of the rewards that an indexer gets by giving them some tokens. And the more tokens you give them, the more rewards they proportionally get. So there's all these economic tricks that you're trying to do. And we have a student from Berkeley in California. We have a person from Otago right now going through and calculating our economic models, running them through different scripts to simulate network activity at different scales and what should the coefficients be of these rules. So it's a really interesting kind of problem around the economic part of it. It's not just the technology, it's the economic part, the economic model as well. We got a long road ahead though. So one of the biggest misconceptions, and I talk a lot of people about this, is that you don't have to be a rocket scientist to be in blockchain. And Gareth used to work at Ambit, and I think right now there are two industries in software that probably I think are the most sexiest industries, and that is AI and ML and blockchain. I imagine an AI engineer needs to know have a lot more experience in AI than what we needed a blockchain engineer. Blockchain is so new that no one's really done it before. It's like you can't really hire in New Zealand a blockchain engineer. They don't really exist. There's really like enough people to fit in this room of blockchain engineers in New Zealand. So it's really about learning, and it's learning while we're in this industry process right now. We're currently in the stage about here where we've built these core fundamental blockchains. We're now building the protocols, the rules, the kind of the logic that happens on them. And next we need to build the apps so that my parents can start using those. My parents can start accessing something that's running on the blockchain without knowing that it's on the blockchain. And this is a transition point we're taking through. And think about these apps. Yes, these blockchains, these protocols, yes, they're like the layer 0 on the internet, right? They're like knowing your TCP/IP kind of protocols, which no one these days knows, except for a few people maintaining one rare GitHub project that is underpinning the entire internet, whatever. But these apps here are all traditional, using React, Node.js, or Angular, Ionic app development. So yes, there are opportunities for C++, Solidity, and Rust people, but just as many for full stack engineers in this industry, because we still need those applications that access and make access those blockchains easier. So really the key part of blockchain is you work hard, you're working remotely. All of our customers are overseas. I'm usually on calls till about 11 p.m. at night, talking to Europe. Everyone's around the world, but you kind of help change the world. You choose something different. We might find it doesn't work in 10 years' time, but at least we tried. We did something new. And this is what's interesting about OneBlock Plus, which is sponsoring this event. They have a fantastic Substrate course, which is one of the coding languages. Substrate is built on Rust. It's a framework on Rust. That's excellent to try out. And that's, if you want to get into blockchain, it's a great way to start. Or even just start with Solidity. Solidity is the JavaScript of blockchain. It's one of those languages that kind of suck, but everyone knows it, so it's kind of here to stay. So learn the fundamentals and get stuck in. There's nothing stopping you. I think that's it for my slides. Yeah. Any questions? You go for it.
Just on the, it was really nice presentation. Just on the this page here, you've got blockchain and protocols,
and then apps.
How long do you think, like, to speak relatively until it's all fully functioning sort of ecosystem?
I think it's like a 5-year thing.
5 years.
Yeah, I think we're getting some stuff that, like, it depends on like how experienced you are. Like, I can use some pretty cool apps to do some pretty cool things.
Yeah, but that's mainly just for the geeks.
Yeah, for the geeks and stuff. But like slowly it goes from geeks to the average person, the parents. Yeah, and that's going to be a spectrum of time, right?
Yeah.
I think it'll be 5 years before my parents be using it. I know my parents were already asking about it, like, what's this big thing up there? Everyone's heard about it, right? I just want to make a point that one of the biggest pain problems for us in this industry is this like retail investment focus right now. And people don't even know about blockchain, but they know about Bitcoin, they know about Dogecoin, and they know about some other shit coins out there because that's where the money is and that's what the media focus on. But beneath that surface of that, there is technology that a lot of people are working on that is really quite new.
Most people don't know about Web2 though.
Well, yeah, like you'd have to kind of be shown that this is the classification for what you're currently in. Yeah, for now it's just like this is the internet because it's the internet we've known for the last 10 years. You know, like we've lived in this internet for the last 10 years where we've expected that I go to Facebook and I see my Facebook post and I jump over to Google Plus and oops, I can't see my Google Plus post anymore because that turned off and I've lost that.
So do you feel like it will be more like the tech side of things will happen in about 5 years, or do you think
I think the application side
will happen longer?
So for example, I think a really good example, and this is like NFTs. Okay, NFTs got a huge amount of like interest right now for the wrong reasons, right? It's like people making random art or like profile pictures and selling them for ridiculous amounts of money. It's a big bubble. But really, what NFTs were designed for was like tickets. I think like I'd love to see a ticket. Like you buy a concert ticket or you buy an airline ticket, you should be able to like, I should be able to sell that to someone else without having to basically like do flight swap NZ on Facebook and like illegally hop on a flight that I haven't quite bought. You know, like you bought a seat, it's your seat, or you bought a spot to that concert, you should be able to pass it on without going to some really shady marketplace. So NFTs were kind of designed for tickets in a way, where you could buy a ticket in the form of an NFT, and there's only ever one of those in existence, and you can trade that NFT around the world. Another example would be, I think gaming companies are really close. There's a little bit like a backlash against some gaming companies that have looked into this, but like an NFT is you win a you know some attachment for your character in a game. That is an NFT, and this is the whole metaverse play that Facebook's talking about. When Facebook starts talking about the metaverse, which is a whole blockchain thing, you know the big daddies are in the game now. But you know, you go into a game, you win something, or you get awarded something, or you buy something. That's an NFT. You can take that from one game to another. Okay, because it exists outside of the game. The game connects to it and says, okay, well, here's your account. What NFTs do you have? Can I put those? Yes, I can. So we accept that kind of standard, and we'll allow you to put your data on your character. And every other game allows that, right? That's a perfect example of something that could happen very soon that would bring blockchain to the masses.
Yeah. Do you think those NFTs will connect to current gaming like that we have? Because I feel like that's the massive thing. People are like, you know, this project's 2 years away.
Yeah.
So how?
Well, that's an example that could be done really soon. I remember there was like a month ago, there was a Twitter post of Steam or something that posted about it and got a huge backlash and basically like turned around and said, oh, because of the environmental impacts of blockchain, we're not going to go down this path. Which, as I've said, like is another common misconception about blockchain. Yes, the two biggest networks, because of all the retail interests going in there, are environmentally horrible. It doesn't, you know, you don't ban cars because leaded petrol is bad to the environment. We've kind of moved past that now.
Conscious of the time.
Yeah,
One
sorry.
more question. Or anyone from online, anyone from Zoom, if you want to have a question for James, this is your chance. You can unmute yourself and ask your questions.
Some questions in the chat.
We take a couple more questions and then we'll move on to Gareth.
It's a great question. Like, what's the difference between Web 1 and Web 3 in terms of just like, are we just iterating to get back to XML? Yeah, like Web 1 is like defined as like defined as like read-only content really primarily. So yes, XML has been around for a long time, but Web 1 is more around the read-only aspect of it rather than being able to. But Web 3 you can still provide user-generated content. It's just more interoperable. Versus Web 1, it's read-only. You get what you're given. You can access it in happy days.
I don't believe you.
You don't believe it?
Because the client-server relationship is not the direction that you think it is. if I am the one running the server, and I am the center of my own universe, then why should I be letting Google or Facebook or one of these other centralized monopolies touch my identity? To decentralize requires giving up some identity and realizing that it's for the greater good. What do we actually all have in common? And I don't know whether XML is that, but it seems like Web 1 standardized it after a while, and Excel decided that they were going to have XLSX and DocX for documents, and now we've gone to Google Docs. And we're just falling back on the same technologies underneath. I'm at the opposite end of the spectrum completely in embedded hardware, so, you know, it's just interesting to see you guys continuing to buy the same things, but the opposite way around.
Yeah. Well, I guess the thing about Web3 is you have the choice of not letting, as a consumer, you have the choice of like yeah, it's a few things unpacked there where maybe we have a conversation after this. Might hop on the Zoom call after.
Cool.
Peter, because well over time.
Yeah. All right. Should we? Thank you very much, James. Appreciate that.